Hello everyone and welcome back to another project. In this project I'm going to show you on how you can detect the drowsiness or the sleepiness of a person as well the yawn. So first of all I'm going to talk about the features of my project, then I'll be showing the components that I've used here, and finally I will show the demonstration the way the project works. So first of all, for the computer vision part for detecting the drowsiness or if a person is having yawn, I have written a Python script. I have used the face mesh module from MediaPipe and extracted 468 facial landmarks. And by using the landmarks of the eyes and the lips, I have been able to, and by doing some kind of tunings and establishing some conditional logics, I have been able to detect the drowsiness or if a person is having yawn. So it's a significant problem. That's because of the fact that most of the road accidents that take place in our country or worldwide, that is one of the major reasons behind the accidents is the drowsiness or the sleepiness of the drivers. So in this project I'll show you on how you can detect the drowsiness of a person as well trigger a real-time alert so that the person gets a work once again. Of course, it will play an important role for driver as driver assistance, and eventually play an important role, in order to prevent the road accidents. Also, the project can be applied to monitor the employees if they are sleeping in their during their work time or they are working properly. And I will also be logging the information when the person is feeling sleepy and when he's having yawns in this Excel file with these entries like date, time, and the state, whether whether the person was having yawn or he was feeling sleepy. So of course, the drowsiness detection problem is indeed significant, especially for driver assistance. So that's all the project is going to do. It's a computer vision based project, and right now I'm going to talk about the components that I've used here in order to implement the project, accomplish my goal, in other words. So there are two parts for accomplishing the computer vision based portion. I had to write a Python script, and I'll be running the Python script on my computer on the Python kernel, but later on I will be deploying the entire stuff on Raspberry Pi in one of the later videos I'm going to show you. And for generating the real-time alerts, as you can see, this is my circuit that I've designed. So as the microcontroller, I have used the ESP32 board, as you can see. And as the alert, I will be flashing this red AC bulb along with a buzzer, as you can see. So this is the buzzer, this is the AC bulb, and here is my microcontroller, which is the ESP32 board. So the bulb is AC, and the control signal generated by the ESP board is DC. So in order to switch the AC load using the small DC control signal, I had to use this relay module. I believe you can see that this relay module over here. It's a 2-channel relay module. That means it has 2 channels, and if you want to, then you can simultaneously switch 2 loads using this relay module. And it's a 5-volt relay module, so it has to be powered with 5 volts, and to serve that purpose I have used this pair of batteries over here. As you can see, each of them are 3.7 volts lithium ion batteries, and a pair of lithium ion batteries here generate around 8 volts when they're completely charged, but the relay runs with 5 volt, so I had to step down the voltage using the linear voltage regulator LM7805, which is right over here. So the voltage has been stepped down to 5 volts and then fed to the relay module, which will be eventually used for switching this red AC bulb. So that's all about the circuit that I've designed here. And right now, with all this done, I would like to directly dive into the demonstration. Well, before diving into the demonstration, one more thing, that I have established communication between my computer and the ESP board using serial communication. That means there must be a wired connection between the computer and the ESP32 board. But if you want to, then you can also transfer information following information from Python to ESP32 and vice versa by generating a local server on ESP32, and then by importing the request using Python, you can simply send the request, send the request or send any information, any data to the server, and the ESP32 board can extract the server, extract the information, extract the data from the server, and generate the control signal according to that. So as drowsiness or yawn is detected, some data will be sent to, in our case, some data will be sent to the ESP32 board from the Python using serial communication, and by reading the information, reading the state of the information, the ESP32 board will be generating the alert. So with all done, I would like to directly dive into the demonstration right now, and I'm plugging my ESP32 board and ensure that the battery is connected. It is connected. So right now I will be running my code. So let's wait a while. Okay, this portion, yeah, as you can see, I have a window right over here, and it's showing my eye on the left side. As you can see, on the left side you can also see the FPS, or the frame per second count, that will help us to detect the resolution of the to detect the quality of the image we are having while performing the entire operation. So you can see a virtual zone over here. So I will be extracting the facial landmarks once a face is present within this virtual zone, within this rectangle, as you can see. So if you are out of this virtual zone, then the code is not going to work, as you can see, and the code will be running, I mean, the drowsiness or the yawn count or detection will be running only and only if the face is within the virtual zone, as you can see. So only then you can see the drowsiness count and the yawn count appears onto the screen. So this is my screen, which is continuously having the having my video from using the webcam, and the resolution is not that much good. I admit that fact. The resolution of my camera is not that good. So you can see the drowsiness count and the yawn count, and it will be reset once the face is out from the virtual zone, as you can see. So on the left, as you can see, I have two plots, the blink plot noted with X and the leap plot noted with Y. So these normally give me the separation, the normalized separation or the vertical separation between the upper and the lower point of my eyes. The normalized vertical separation, I should have said, because I have normalized that with respect to the horizontal separation between the endpoints of my eye. And the Y plot is the leap plot that eventually gives me the separation between my upper and, okay, it has detected drowsiness for once, whatever. So the Y plot, it shows you the normalized separation between the upper point and the lower point of the leap with respect to the end points of the leap. So after doing some kind of tuning and calibration, I have been able to extract a threshold below which will be detected as a drowsiness or yawn. So right now I would like to show the demonstration. Let me reset the values. Well, you might have seen the alert being triggered. That's because of the fact that while I was talking, maybe my mouth was in the structure of yawn, or maybe my eyes were closed for above the threshold value, and that's why the alert was triggered. But as I'm out of the virtual zone, you can see that no alert is triggered, no detection is made. So right now let's see if it works. So if I'm feeling sleepy, then my eyes will get smaller. So you'll see that an alert will be triggered and the drowsiness count will also be increased by 1. So let's see if it works. So as you can see, I'm feeling sleepy, my eyes are closed, and the alert has been triggered. Drowsiness count must also have been raised. As you can see, it's been raised. So let me check it for one more time. What happens if I feel sleepy? You can see that the alert has been triggered, and the drowsiness count has also been raised by 1. And there must be some kind of a rectangular pop out when I was in drowsiness, when I was feeling sleepy, I should say. And then let's check the yawn count. So if I'm having yawn, that would be detected right now, which is the Y plot, in other words. So the yawn count will be raised by 1 right now, and there will be alert triggered. So let's see if it works. I believe I have been able to show, and the curve also gets red once the alert is triggered. So let's show the drowsiness demonstration once again. You see it's working. You see it's working perfectly. So let me exit it from here right now, and let's see the log if it's working properly. So let's go to the log. It must be in the computer vision somewhere around here. Hold on a bit, I'm going to show there. C vision, no, not here. OpenCV, where is OpenCV? Let me check. Yeah, it's over here. And Drowsiness log, it must be available here. As you can see the log, let me increase the separation a bit for better understanding. Yeah, you can see the date, time, and the state. So as you can see, it's 12:28. The time is 12:28, and the state is yawn, sleep, and dot dot dot. So each time you are having yawn, or each time you are in drowsiness, the information will be logged into this Excel sheet. So that's how the project works. I hope you liked it. I believe it will play an important role in case of preventing the road accidents. It will act as an important tool for the drivers as driver assistance to prevent the road accidents. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.